on one side. That could be angle, side, angle, or angle, angle, side. But if you know two angles on one side, you can always find a matching angle and its corresponding side to use the law of sines. And yesterday we did the ambiguous case, that bad word, more work, got to check for the second triangle. That's always side, side, angle. Never do you ever have to check for a second triangle if it is not side, side, angle. And if you have side, side, angle, you always automatically have a matching angle with its opposite side. Well, the other given informations would be, what if I give you two sides and the included angle? Then you don't have enough information to get a pair, a corresponding side and opposite angle. And if I give you side, 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 all three sides, and you have no angles, you don't have a pair. So law of cosines takes care of those other situations. So it's going to be side, angle, side, and side, side, side. Okay. We'll do a proof of the law of cosines. It's a coordinate proof. So I'm going to be working on the coordinate plane using, like coordinates, x, y's. But I'm going to be writing all my x, y's in a's, b's, and c's. Now, I won't ask you to prove the law of cosines, so don't get too hung up if you're not following exactly, but it's good for us to have some exposure to different proofs. So I'm going to start by drawing a triangle on the coordinate plane. And I'm going to label its coordinates A, B, and C. And then I'm going to label its sides A, C, B accordingly. Okay. Now, in order for me to do a proof that involves coordinates, I need to know what the coordinates of those vertex points are. So help me out. What's the ordered pair for vertex A? 0, 0. What's the ordered pair for vertex B? C0. I'm just going C to the right. Okay, that's the side length. Point C is a little bit tricky, right? Because we don't really know if we're exactly half or where we are here. We're going some distance x to the right and then some distance y up. But that forms a right triangle. So now I can use some right triangle trig. Okay, and I'm going to be looking from cosine A right here, from angle A. And I'm going to start with the cosine of A. The cosine of angle A is equal to x over b, adjacent over hypotenuse. So now I could solve for x by just multiplying by b. And the x coordinate is b cosine A. And likewise, I could set up a trig ratio to solve for the height, y. I don't want to use tangent of A because tangent of A would include x and y. So I'm going to use the sine of A. And that, of course, is going to be b sine A. So the reason why I did that is, remember in these law of cosines problems, I'm either going to give you side, angle, side, or I'm going to give you side, side, side. So I'm giving you lowercase ABC or uppercase ABC. So we want all of our coordinates to be in those terms. Okay, so now I have coordinates. We're going to set up one of the law of cosines where you find a side length. And the side length that I'm going to find is A. So from your time in geometry, algebra, probably middle school, you know distance formula. So we're just finding the distance between these 2 points. So instead of D equals, I can say A equals. And I'm going to do the square root of x minus x. Right, the x coordinates. So that's going to be b cosine A minus c. And that's going to be quantity squared. Plus y minus y. I really like this. b b sine a minus 0 is just b sine a. So if you're okay with that, I'm not going to write minus 0. We're running out of space. And then, I don't want to keep writing just radicals, so I'm going to square both sides. So I'm going to have a squared equals. I'm going to FOIL out b cosine a minus c times b cosine a minus c. So when I multiply the first terms, I'm going to get b squared cosine squared a. B cosine a times b cosine a. And then my outside terms, I'm going to get a negative bc cosine a. And the inside is going to be the same. Negative bc cosine a. So I really have two that are negative. bc cosine a. Yes, I am. Thank you. I thought it looked nice. bc cosine a. There you go. And then my last term, negative c times negative c, is plus c squared. And I'll just squeeze this here on the bottom. When I square b sine a, I'm going to get b squared sine squared a. So I'm just like algebra, some ugly things, right? Now, there are two like terms in there. They can be hard to see, but these two terms both have a b squared in them. So like if I had 5b squared plus 2b squared, I could add that and make 7b squared, right? That's 5 plus 2. In this case, I have a sine squared a and a cosine squared a that I would have to add together. Or you can think about it like for these two terms, if they both have b squared, you can factor that out. So that's going to leave me with a squared equals b squared times the sum cosine squared a plus sine squared a. And then I'm going to rearrange. I'm just going to write these in a different order. Plus c squared minus 2bc times cosine a. And what's really nice about that rearranging I did, cosine squared a plus sine squared a is equal to 1. That green identity. So now I just have a squared equals b squared plus c squared minus 2bc times the cosine of a, which is a law of cosines. Cool. Does that look familiar? It doesn't? Oh my gosh. Yeah, it should. Okay. So now we'll write down the law of cosines for like our notes purposes. So we've got one version, a squared equals b squared plus c squared minus 2bc times cosine a. That's if I'm solving for side A. Now, I will say, if you go back to that coordinate proof, if you try to solve for b and c in the picture that I had on the board, you'll get some very uninteresting results. b equals b and c equals c. Well, if you don't know b or c, knowing that is not helpful. So in order to get the other versions, you'd have to like draw a new triangle or just like relabel your vertices so that a new vertex was at the origin. But we can also just write the other versions. If I change a out for b, so like let's say I want to solve for b, then everywhere I see b on the other side, I'm going to write a. So this would be a squared plus c squared minus 2ac, and then instead of writing cosine a, I'll write cosine. And of course we have one for c squared too. Now, you are responsible for law of cosines for Friday's quiz. I certainly wouldn't memorize 6 formulas. I'd know one and just be able to, plug in other numbers or other letters if I needed it. Okay. Now, these are when you want to find a side, right? So in the two versions that we talked about, law of cosines is for side angle side or side side side. We're using this if it's side angle side. Two sides and an included angle go straight to law of cosines. Law of sines won't work. Now, we have another version of the law of cosines for if you're trying to find an angle. Because if I give you three sides, you're not going to need to find a side. You're going to need to find an angle. So I'm going to do a little bit of algebra up here at the top. To get the other version of the law of cosines, what you're essentially doing is solving for cosine A. So like think about reverse order of operations. What do you need to move away from cosine A first? All right, order of operations, reverse order of operations, we will do what? Subtract b squared, subtract c squared. Anything added or subtracted needs to be moved to the other side. So we'll have a squared minus b squared minus c squared equals negative 2bc times cosine A. And then we just have to divide by negative 2bc. We talked about this with our power reducing formulas. We don't like to leave a negative in the denominator of a formula. To just get rid of the negative, change the sign of your numerator like you had divided by the negative. So we'll have cosine A equals b squared plus c squared minus a squared all over positive 2bc. So then you don't have to remember negative. And then there's a version for every angle, right? Cosine B equals what? A squared plus c squared minus b squared over 2ac. And cosine C equals a squared plus b squared minus c squared over 2. Okay. So to me, there are really two formulas for the law of cosine, but again, they're really just one formula. One is solved. You need to be able to use them on Friday, yes, and memorize them and know them. This should not be our first time seeing them. Okay, so we got to do some examples. You'll need a calculator, so have a calculator out. Make sure that it's in degree mode. Think about this example if it were just a question on your quiz on Friday. Let's say it was number 3. You know, they won't be separated by law of sines and law of cosines, so you'll have to be able to decide which one to use. Why would we not use law of sines? You have no pairs, right? You don't know an opposite angle and opposite side to match, so you have to use law of cosines. What should we solve for first? Side B. So we're going to say b squared equals 19 squared plus 22 squared minus 2 times 19 times 22 times the cosine of 81. If it's side angle side, you're going to solve for the missing side first. I actually really like the law of cosines. I prefer it over the law of sines because to me the law of cosines is basically just plug and chug. Right? Yeah, I don't know why you guys giggle every time we say it. It's like the normal math thing. Your teachers never told you to plug in chug before? Plug in the numbers and you chug out the answer. Like a little choo-choo train, right? Yeah. Come on. All right. Now, you've got a calculator. All you got to do is type that whole thing in your calculator. Just type it all in. Oh, I'm peeking at Riley's answer. She got 714.22.
What is it?
That is not what
Yeah.
I got 700.
Well, check your numbers. You typed something in wrong.
What? Oh, I multiplied.
See, Hannah multiplied. Found her error.
I did 19 squared times 22 squared.
Okay, time to try that.
Okay, it should be
Plug and check.
Is you guys agree, Mouse?
See, I used a bunch of.
Go back.
Oh,
Go back to your work. You can't use that negative. I think it's doing a multiplication. You have to use it. You should get 714.22 on your first go. Is that your actual side length? No, you have to square root it, Tyler says. What is that number then?
26.72.
26.7. Cool.
Wow.
I will do this now.
That was so little work. You didn't do any calculations. You just plugged it in. The calculator chugged it out. Yeah. Okay, I want to go back to my formula page because I forgot to mention one really important thing that you should write down. Okay. Word of warning. If you are using the law of cosines and you only know 1 or 0 angles, always make sure you have found the largest angle before you move to a law of sines. Now, I like to just work in law of cosines because I love law of cosines, so I don't have this issue. But some people are really partial to law of sines, so once they get their information from law of cosines, they switch right over to law of sines. Only do that if you are certain you have your largest angle. The reason why is cosine, when you do inverse cosine, you'll get answers in that half moon in quadrants 1 and 2. You'll get an answer between 0 and 180. And so you'll know if you have an obtuse angle for your largest angle. If you were to switch over to law of sines only gives you your answers positive or negative in quadrants 1 or 4. And so it may give you a misleading answer. It might give you a positive angle in quadrant 1, but the actual angle is the supplement to that. That's where the obtuse angle would come from. So to avoid that whole issue, and how will you know that that's happened if you're certain you did all your mathematics correctly, and then at the end, your largest side isn't opposite your largest angle? It's an issue of switching over to law of sines, and it should have been a supplement. Okay. So the easiest way to remedy that is, if it's a law of cosines problem, make sure you found your largest angle before you ever switch out a law of cosines. So we found the missing side is 26.7. Looking at what you know, do you know your largest angle? Yeah, because the largest side is 26.7. We know the largest angle in this triangle is 81, so I don't have to worry about any other angles being obtuse because 81 is the biggest one, so they're all acute. So if you wanted to find the other angles, you could switch over to law of sines. Since we're learning law of cosines, I'm going to do law of cosines, and I'm going to find A. So I would say this: the cosine of angle A is equal to, I use the two sides that surround that angle and add their squares. I don't know why I wrote 0.67. Is it 0.67?
No.
Oh, it is.
No, it's points.
Okay, I don't know why I wrote that. And then you always subtract the side that's opposite, it's square. And then divide by 2 times these first two numbers, the two that are including the angle. So 19 times 26.7. Now, I know this is going to come out to an acute angle because I already have my biggest angle. But just in terms of like practicing law of cosines, we'll do this one. Now, when you're typing that in your calculator, because you have plus or minus in the numerator, and because you have multiplication in the denominator, you would need like a big set of parentheses, right? Okay. And you should get a small number because it should represent the cosine. So, everybody do that. Yeah, Anna got 0.5814. Just cheating off of everybody today. Okay. So that's not your angle, right? What do you have to do to get your angle? Inverse cosine. It's the cosine of A that's equal to 0.5814, so you just inverse cosine both sides. Now, I would probably in my calculator just do second cosine, second negative. That then looks like inverse cosine of my answer, ANS. And A is, give me to the nearest tenth, 54.4? Is that what you're saying? 54.5. Okay? Questions, concerns about what I did right there? I love it. It's just putting the numbers in, and then I put in my calculator, and I inverse cosine, and I'm on my way. I don't have to do that whole cross, multiply, divide, inverse sine, that kind of thing. Finding the missing angle C would be really easy, right? 180 minus 81 minus 54.5. So what do we get right there? 44.5. Okay. Any questions? I'll look at your calculator, Hannah, if you're not getting the right answer. You got it? Okay. Any questions? Okay, so I may not work out the whole next example, but I just want to show you an example where you have the other case. Instead of side, angle, side, you have side, side, side. Again, think about on your quiz on Friday. You'll be all alone working, and you'll have to decide if you're doing law of sines or law of cosines. Well, obviously I'm not doing law of sines, so I've got no angles. So I'm going straight to law of cosines. Which angle would you like to solve for first? YB. It's the largest angle. So always keep that rule in mind, right? Find the largest angle first. If B is obtuse, law of cosines will get it for you right away. Okay. And if B is not obtuse, then it doesn't matter if I use law of cosines or law of sines for the rest of the problem. As long as I found the largest angle first. What is that? 8 squared plus 10 squared minus 12 squared over 2 times 8 times 10. I'll remember my big sets of parentheses there. And I don't think this one comes out to be obtuse either. So let me know what you get for that value. 82.8 is the correct answer. Okay, then I can use another law of cosines. I could switch to law of sines, and then I could subtract from 180. So I'm just going to write keep working, right? I haven't solved it, but I'm not going to. Me personally, I just keep using law of cosines because it's so easy to just plug in my calculator and be done. Plug and chug. If you wanted to go to law of sines, that is okay as long as you have the largest angle first. Okay, last thing. Another area formula. Heron's formula. So it's called Heron's formula because it's named after someone, but it's just another formula for area of a triangle. And as you're jotting it down, it looks really sort of long and arduous, but it's not so bad. I'll describe it once you get it written down. Okay, so, think about areas of triangles or area formulas you know. Base times height divided by 2, you use that for right triangles, right? Area equals 1/2 A times B times sine C, we talked about on Monday. We use that if we have two sides and their included angle, side angle side. So when you're looking at Heron's formula, all the things that you're plugging into it are lowercase, so those are side lengths. So we're using Heron's formula when we have side, side, side. So if you knew all three sides of a triangle that wasn't right, you wouldn't have to go through all the work of finding the altitude. You could just plug it into Heron's formula. Now, in addition to these lowercase a, b's, and c's, there's this s that keeps appearing. And then behind the formula, there's a description of what S is. Okay. And it's like, oh my gosh, now I have to remember a formula and another thing. Okay. It's easy if you know what S stands for. S is called the semi-perimeter. Semicircle means half of a circle. So this is half of your perimeter. How would you find the perimeter of a triangle? A plus B plus C and divide by 2. Now remember, if you put that in your calculator, put it in parentheses. Okay. So you find half of your perimeter, and then you put that in for all those S's. It's the same. Okay. So we'll do one quick example so you can see how the formula works. I can tell from the list that everything is lowercase, so this is a case of side, side, side. Or if you see it visually, you would see all the sides are named. Instead of finding the altitude, I'm just going to go straight to Heron's formula. So before I do Heron's formula, I need my semi-perimeter. 22 plus 8 plus 15 divided by 2. 22.5. Your semi-perimeter is always longer than all of the sides. This one, not by much. It will always be longer than the sides. And then you just plug it in. I'll say plug and chug again. Why not? Plug and chug. Did you guys think you were supposed to be like chugging a glass of chocolate milk or something? Is that why you Google? Chocolate milk is so delicious. That's why. Okay, so then you just put that in. You do the semi-perimeter times the semi-perimeter minus all the sides. And just be aware in your calculator, when it opens that parenthesis at the beginning for the square root, do not close it for the first semi-perimeter. Then it will only square root 22.5 and it'll multiply by everything else. You would actually have like a double close at the end, so leave it open. And then add in all your other parentheses. This one, I think it's in the 30s. 34.9. 8 square units, okay. Units squared, however you want to write it. So on your quiz on Friday, there will be some questions where you have to, you see two triangles and you have to calculate area. You'll have to decide which formula is appropriate to use. Okay, we've got just a couple of minutes left, so you do have a homework assignment. What is it again? About 10 problems today? Doable. So do it. I appreciate it.